Okay, so we talked about hearing. Now we want to talk a bit about balance. Okay, so ear works with the brain to control balance. And it's a liquid in your inner ear responsible for balance. Okay, so we want to look a bit about this. So rotational equilibrium. And again, if I spin around in my chair here, what that's going to do is cause fluid in my semicircular canals to still start moving. So imagine taking a glass of water and all of a sudden like swirling it and then stop swirling the glass of water, stop moving it. Does the water still move? Yes. And that's what happens in your head too. So each fluid-filled canal or ampulla contains hairs, cilia, that move when a gel-like cupella is pulled by gravity or centrifugal force. Movement causes the fluid to bend the cilia, initiating nerve pulse sent to your brain. Okay, in which areas? A cerebellum, right? That would be part of it, coordinating with the cerebellum. Now, head position is gravitational equilibrium. Uh, this is not the same as semicircular canals. Occurs in the saccule and the utricle of the vestibule. So just go back and check that section of your notes. Where's the vestibule? We're not dealing with semicircular canals anymore. You've got little rocks called otoliths, tiny stones of calcium carbonate inside. And when you turn your head and move it sideways, for example, what happens is these little stones, gravity, pulls these little stones down, bending hair cells. And you can tell that your head is moved sideways. So when the head bends, gravity pulls the otoliths and the gelatinous material causing the hairs to bend, which stimulates sensory receptors impulse to the brain. Okay, so this is showing the difference between, um, and this is just a diagram in your book, right? We're going to say the balance, semicircular canals, utricle and saccule, okay? And here we go for B is rotational equilibrium. I'm going to spin around. I'm so happy, okay? And gravitational. I'm going to bend my head, okay? Hair cells of the utricle saccule bend. With rotational, it is the cupella in the semicircular canals, right? Semicircular canals. Okay, so spend a moment just looking at those diagrams and read through that carefully. Again, watch the video. It will help a lot. Taste, 5 types of tastes, okay, with dissolved. So this is a chemoreceptor. It's not mechanical, it's not photo for light, it's chemicals, chemoreceptors in our tongue. Um, umami, that was only discovered fairly recently. Smell, this is also chemoreceptor. Detection of a specific airborne chemical that stimulates the olfactory cell produce action potentials, and that would be perceived in the olfactory bulb. Remember, that's actually part of the forebrain. It sits just underneath the frontal cerebral cortex. Okay, olfaction is a sense that enables organisms. Okay, the area of the brain where odors are interpreted is the cerebrum. Yeah. Okay, skin receptors, these are mechanoreceptors. Touch. Now look, you've got free nerve endings for pain, heat, and cold. Touch receptors, touch, touch, touch. Pacinian is for pressure. Okay, all these different receptors. Again, nice little video on this. Okay, so we've looked at rods and cones, we looked at the brain, looked at mechanoreceptors in the ear, proprioreceptors. We, there was a trippy little video I asked you to watch on that. Okay, muscle joints, tendons help the body maintain the balance. Okay, thermoreceptors in the skin, chemoreceptors for taste and smell. Okay, and here's some practice questions you can take a look at, see what you come up with. Okay, now for assignments, what I'd really like you to do is just do pages 10 to 12 in the workbook and get those completed, and I'll post an answer key for them. And, if you want to do extra questions, this will really solidify your knowledge.